Myself from LJIET of Engineering and Technology. Okay, so in last session we started a new chapter, that is Flywheel, and we also discussed some topic in last lecture, that is how to determine fluctuation energy, and also we discussed about design of flywheel. Also we derived the equation for the design of flywheel. Clear? Also we discussed about how to find diameter of flywheel, how to find thickness of flywheel, how to find cross-sectional area of the flywheel ring. Clear? So in today's session we have to discuss application of flywheel in punching press. Clear? So what is the application of flywheel in punching press? Clear? Flywheel also using the 4-stroke engine, in 2-stroke engine. Clear? Flywheel mounted in engine at the end of the crankshaft. Clear? Flywheel, what is the function of flywheel? Function of flywheel is to store the kinetic energy and deliver kinetic energy whenever we require. Clear? So this is the main function of flywheel. But flywheel also using punching press. Clear? What is the function of punching press? Punching press function is to drill a hole in the plate. Clear? So what is the application of flywheel in punching press? So flywheel store energy and deliver energy to the slider crank mechanism. Clear? In the punching press. So you all know what is the function of punching press. You see in this figure, there is one punching press is there, flywheel mounted on punching press. Clear? And in punching press, punch move upward and downward direction cycling and drill hole in one plate of material. Clear? So this is the application of flywheel. So in punching press we have to deliver power in constant rate. Clear? So motor, electric motor supply power to the flywheel and flywheel power supply to the slider crank mechanism. Clear? In punching press our piston is work like a punch. Clear? And we require energy whenever punch come in contact with the plate. Clear? So you see in this figure, there is one flywheel is there, one electric motor is there, and one slider crank mechanism is there. Clear? In bottom side we put one material, plate and die. Clear? So motor, electric motor supply constant power to the flywheel and flywheel supply power to the slider crank mechanism, and slider crank mechanism due to crank and connecting rod the piston movement is cyclic up and downward direction. Clear? So in this case piston is work like a punch. Clear? And we require energy whenever punch come in contact with material plate. Clear? Because we have to cut this material plate. Clear? So during one revolution piston move one time downward direction and one time upward direction. So during one revolution of crank there is a 2-stroke, one downward stroke and one upward stroke. So duration of one revolution, that is 2 pi. Clear? So during one revolution one hole is drilled. Clear? But we require energy only the portion that we have to cut the material. Clear? The cycle is 0 to 2 pi, but we require energy only when we have to drill the hole. Clear? So in this case there is two type of energy, that is two type of energy is capital E1 and capital E2. So capital E1 energy indicate energy required for one punching operation. Clear? And what is E2? E2 means energy required for actual punching. Clear? So duration of E1 energy, that is 0 to 2 pi, because E1 indicate energy required for one punching operation. And E2, what is E2? That is the energy for the actual punching. Now actual punching occurs during theta 1 to theta 2. Clear? So actual punching, duration of actual punching is theta 1 to theta 2, that is theta 2 minus theta 1. Clear? So you have to remember that there is two type of energy. Capital E1 indicate energy required for the whole punching operation, and capital E2 indicate energy required for actual punching. So duration for E1 energy, that is 2 pi, and duration for the E2 energy, that is theta 2 minus theta 1. Clear? So this is the punching, working of the punching press. Clear? Motor supply power to the flywheel, flywheel store some energy, and this energy will run slider crank mechanism, and slider crank mechanism drill the hole in the plate. Clear? So this is the working of punching press. Now what is energy U1? I also already told you that is energy required for one punching operation, and what is E2? That is energy required for the actual punching. Now we have to some notification we have to consider, that is D1 is equal to diameter of the hole, small d1 is thickness of the hole, and tau is equal to ultimate shear stress. Clear? Now in this case shear stress come in picture because we have to shear the plate for the drill hole. Now what is shear area of the hole? Clear? Now diameter of hole is d1. So what is the perimeter of hole? That is pi into d1. Now if we want to find the area of the hole, then we have to multiply this perimeter to its thickness. Now what is the equation of the perimeter? That is pi into d1. If we multiply this perimeter to its thickness, then area of the sheared hole, that is pi p1 into d1. Clear? So this is the sheared area of the hole. Clear? Okay. Now maximum force required for punching, that now you all know what is the relationship between stress, force and area. So what is the equation of stress? That is force upon area. So based on that you can write down area is equal to shear stress in force is equal to shear stress into area. Clear? So shear force is equal to shear stress into area. So equation of the area is pi d1 into t1 into ultimate shear stress. So this is the equation for the force. Now therefore work done or energy for the punching operation, that is E. You all know what is the equation of energy, that is 1 by 2 F into D, but in this case our thickness is T. So energy for the punching operation, that is E1 is equal to 1 by 2 F into T. Clear? This is the equation for the punching operation or the energy required for the punching operation. Now E2 is equal to E1 into theta 1 minus theta 2 upon 2 pi. Clear? So how this relationship comes? So you all know E1 energy for the 2 pi revolution and E2 energy for the theta 1 minus theta 2. Clear? So based on that you can write down this equation. Clear? Now therefore balance energy equation for the punching. Now you all know what is the maximum fluctuation of energy, that is E1 minus E2. Delta E is equal to E1 minus E2. You have to put the value of E2 over here. Clear? So equation of delta E is equal to E1 minus, put the value of E2 over here. So E1 bracket by theta 2 minus theta 1 upon 2 pi. Clear? Now from this equation you can common the value of E1 and you can write this equation in this form, that is E1 bracket 1 minus theta 2 minus theta 1 upon 2 pi. Clear? So this is the equation. Now theta 2 and theta 1 can be found using the following relation. You all know theta 2 minus theta 1. Clear? That indicate the actual punching, duration of actual punching, and 2 pi indicate one revolution, means 360 degree. Now 360 degree if you convert into radian form, then that is 2 pi. Now theta 2 minus theta 1 you can write, if theta 2 minus theta 1 value is same as the value of thickness of the plate, because punch move downward direction at the crank position from theta 1 to theta 2, and punch move and punch cut this plate. So thickness and arc of between theta 1 and theta 2 will be same. Clear? So instead of theta 2 minus theta 1 you can write T. Clear? And instead of 2 pi. Now during one revolution there is two stroke is occurred. One downward direction stroke, that duration is 0 to pi. One upward direction stroke, that duration is pi to 2 pi. So during one revolution two stroke is occurs. Clear? So instead of 2 pi you can also write down that is 2s. Clear? Means 2 stroke. Now what is the length of stroke? Now you all know in one stroke piston move from top end side to bottom end side, and crank move from theta is equal to 0 to pi. Means it indicates the diameter of the crank. Clear? Now instead of diameter you can write down 2 times radius. So that is a 2 stroke. So 2 stroke, 1 stroke is equal to diameter, and instead of diameter you can write 2r, 2 times radius. So instead of 2s you can write 4r. So final equation is theta 2 minus theta 1 upon 2 pi is equal to T upon 2 times stroke is equal to T upon 4 times radius, crank radius. Clear? So where T indicate thickness of material to be punched and S indicate stroke of the punch, and one stroke is equal to 2 times radius. So this is the working of the flywheel in punching press. Clear? This is the working of punching press. Application of punching press is to drill a hole in material, means in a plate. Clear? So you all know in this case shear stress come in picture, and you all know what is the equation of shear stress, that is force upon area, and area of this shear hole, that is pi d1 into d1. Clear? So in today's session we discuss how to use flywheel in punching press, what is the application of punching press. Clear? How flywheel deliver energy in the punching press. Clear? There is two type of energy, capital E1 and capital E2. E1 indicate energy required for one punching operation. E2 indicate energy required for the actual punching. Duration of E1 energy, that is 2 pi. Duration of E2 energy, that is theta 1 to theta 2, means duration of that is theta 2 minus theta 1. Clear? Fluctuation of energy, that is delta E. Delta E is equal to E1 minus E2. You all know maximum energy minus minimum energy. Based on that, we derive this equation. Clear? So this is the application of flywheel in punching press. So next topic we will learn in our next lecture. Thank you.